So if you work with AI, you definitely know this feeling. You're scrolling to the Hugging Face hub, you find this amazing, powerful new model, you kick off the download, and then you just wait, and you wait, and maybe you wait some more, only to find out, nope, your machine can't even run it. Ugh. Well, today, we're going to look at a super clever little tool that's built to make that whole nightmare a thing of the past.
You know, every time you download one of these huge new models without knowing exactly what it needs, you're basically rolling the dice, right? It's a gamble. You're betting your time, your bandwidth, and honestly, the momentum of your entire project.
I mean, seriously, we've all been there, haven't we? It is probably one of the most frustrating, just soul-crushing bottlenecks in AI development today. You see the potential of a new model, you get all excited about what you can build, and then, bam, hardware limitations just slam the brakes on everything.
And let's be real, we are not talking about small files. Some of these cutting-edge models are just absolutely massive. I'm talking 50 gigs, 100 gigs, I mean, even up to 600 gigabytes. That's a download that could take you hours, maybe even days if your internet connection is having a bad day.
And, this is so much more than just a little inconvenience. It's a huge drain on your resources. But the worst part? It's a failed experiment before you've even had a chance to write a single line of code. It just feels wrong. There has to be a better way, right?
Well, thankfully, there is a much better way. So let's talk about the solution. It's a tool called hf-mem, and it's designed to completely transform that old, download and pray workflow into something way, way smarter.
So, what is hf-mem? At its heart, it's a super lightweight, but really powerful command line tool. It has one job, and it does it brilliantly. It tells you, pretty much instantly, exactly how much memory you're going to need to run a model. And it does this before you even think about starting that huge download. And the real beauty of this tool is just how simple and efficient it is. I mean, look at this. It checks models in seconds, not minutes or hours. It supports all the big players you care about, transformers, diffusers, sentence transformers. It works with safe tensors, which is pretty much the standard now. And this part is really cool. You can run it instantly with UVX, so you don't even have to permanently install it on your system. It's all about being completely frictionless.
Okay, so this is the part that sounds a little like magic, right? How on earth can it know how big a model is without actually downloading the whole thing? Well, it all comes down to this incredibly clever technique. Let's call it the 100 KB trick.
I mean, just look at this comparison. It says it all. The old way, it's just brute force. Download everything and hope for the best. The hf-mem way, though, is surgical. It's smart. It figures out that all the critical information it needs is packed right into the very beginning of the file. This analogy is just perfect. Think about it. You wouldn't download an entire 1,000-page book just to read the table of contents, would you? Of course not. And that's exactly what hf-mem does. The metadata, the list of all the parameters and their data types, is stored right at the top of a safe tensors file. So hf-mem just cleverly peeks at that first page to figure out how big the rest of the book is.
Okay, so here's the breakdown of how it actually works. It's really just 4 simple steps. First, you just point the tool at a model on the Hugging Face hub. Then, it uses a neat little web trick called an HTTP range request to grab only the first 100 kilobytes of each file. That's it. That tiny little chunk has all the metadata it needs, the parameter counts, the data types, everything. And from there, it just does some quick math. It's simple, it's elegant, and it is incredibly fast.
Okay, so that's the theory, which is cool, but let's see this thing in action. What does the output actually look like when you run it on a few different kinds of models?
All right, for our first test, let's go big. Let's throw a real monster of a model at it, a massive LLM, and see what hf-mem spits out.
And boom, there it is. For a beast of a model like this one, with a whopping 228 billion parameters, hf-mem tells us in seconds that we're going to need around 214 gigabytes of memory. And look, it even breaks it down by precision, so you can see that most of the weights are 8-bit. Just like that, with one command, you know if your hardware is even in the same universe as this model. No download, no guesswork, just an instant answer.
Okay, that's impressive for a single big model. But what about something more complex, with multiple parts, like the pipelines you use for image generation? Let's take a look at a diffusers model. Now this is where hf-mem gets really, really useful. For a complex text-to-image model, it doesn't just give you one big number. It gives you this awesome, granular breakdown of the whole pipeline. So you can see exactly how much memory the text encoder needs, how much the main UNet or transformer takes up, and what the VAE requires.
This is just incredible for figuring out where your memory bottlenecks might be, which is absolutely crucial for optimizing things later on.
But hey, it's not just about the giant, monstrous models. This tool is just as handy for the smaller, everyday workhorses, like the embedding models we all use.
So, for a super popular model like this one, a quick check tells us we'll need about 1.25 gigs of VRAM. It's a simple, fast sanity check that basically says, yep, you're good to go. This will run on pretty much any modern GPU. It's that little bit of peace of mind before you start downloading and coding.
So, when you put it all together, what does this actually mean? Why is a tool like this so much more than just a nice little convenience? Well, because it really, fundamentally changes your entire workflow for the better.
Here's what it all boils down to. It's a huge shift in how you can work. You can finally test if a model is even feasible before you download a single byte. You're going to save hours of time and tons of bandwidth. You get to completely avoid those awful out-of-memory errors. And best of all, you can make smarter, faster decisions about which models are actually right for your project and your hardware. It's a total game changer.
You know, this simple change, from guessing to knowing, just blows the doors wide open for experimentation. It tears down one of the biggest barriers we have to just trying out new and interesting models. It empowers you to build more and to build faster. So really, the only question left to ask is, now that you can know before you download, what are you going to build next?